Today we're going to talk about writing equations for ellipses. At the top of the notes, I'd like you to draw on the ellipse these various features. An ellipse has two vertices, one at each end, two foci, and this segment that goes through the vertices, the foci, and the center is called the major axis. The segment that goes the short way across an ellipse is called the minor axis. Notice K again, just like it was for the vertex of a parabola. But now we have more lengths than just the A value. In the parabola, the A value was the distance from the center to the focus. This time, the A value is the distance from the center to a vertex, also known as half of the major axis. So A is the length of half of the major axis. B is half of the minor axis. The points out here don't have any specific name, so we just say B is half the minor axis. And C is the distance from the center to the focus, from center to focus. The way I remember what A, B, and C go with is like this. C is center to focus. They all have a C in them. And A is half of the major axis. That's how I remember it. There's a relationship between A, B, and C, and it looks like the Pythagorean theorem, but it's not, so try not to get them mixed up. The relationship is B squared equals A squared minus C squared. Now, keep in mind, A is always going to be the longest of these three measurements because it's half of the major axis, and the major axis is always the long way across the ellipse. C is just center to focus, so of course A has to be longer than that. B is less than A because it's only half of the minor axis. Now, what happens if A and B are equal? Good question. If A and B are equal, then we end up with a circle. So there's two different versions of the equation for an ellipse, and it depends on if the ellipse is oriented horizontally, also known as parallel to the x-axis. It won't always have a center at 0, 0. And the other way an ellipse is oriented is vertically. So in other words, the major axis of the ellipse would be parallel to the y-axis. In this case, the y-axis is the major axis of this ellipse. So as you write down the two equations for the horizontal orientation and the vertical orientation, notice how they're alike and how they're different. They're both equal to 1. That will never change. They both have addition. That will never change. They both start with x minus h squared. And they both have y minus k squared, just like we saw with the parabolas, x minus h, y minus k. The difference is where a squared and b squared are. Notice when the major axis of the ellipse is horizontal or parallel to the x-axis, A is with x. So the major axis is parallel to the x-axis. When the orientation of the ellipse is vertical and the major axis is parallel to the y-axis, A for major axis is the denominator under the y. So that's how you'll know which form of equation to use. Now in this box over here, these are the exact same thing, and we've already talked about them a little bit. This is the relationship between A, B, and C. That will never change for an ellipse. And just a reminder, A is greater than B. Not equal to, A is greater than B, because A is half the major axis, the long way across, and B is half of the minor axis, the shorter way across. All right, keeping all these things in mind, we're going to write an equation of an ellipse with center at the origin, one focus at 4, 0, and a vertex at -5, 0. Start by plotting all your given information. Center at the origin, so 0, 0, keep in mind that's HK. Center, it's helpful to label our points. One focus at 4, 0, so make sure you're going over 4 on the x-axis. I'm going to label that F for focus. A vertex at -5, 0, so again along the x-axis, -5, 0, label it V for vertex. And now we already know some other things, even though it's not given specifically. The nature of an ellipse is that it is symmetrical. So if there's a vertex on this side of the center, 5 units away, then the other vertex will be over here. I'm going to label this vertex 1, vertex 2. Same thing goes for the focus. If there's a focus to the right of the center, 4 units away, then there's going to be another focus to the left, 4 units away. I'm going to label this focus 1, focus 2. The only other thing we need in order to sketch our ellipse is the length of the minor axis. So remember, A, B, and C have a relationship. B is half the minor axis. And if I can just use this equation, then I can find out what B is. We already know A, half the major axis, center to vertex. We already know C, center to focus. All I have to do is calculate B. B squared is 9, so B is 3. 1, 2, 3, 1, 2, 3, and then I try to sketch an ellipse. Easier said than done. We're going to write an equation for this ellipse. Notice that it is oriented horizontally, and I always start with x squared. We're going to put a squared under the x and b squared under the y, because the major axis is parallel, or in this case, the x-axis. Just remember that you have to actually square A, so 5 squared is 25. Go ahead and multiply it out, don't just write 5 squared. And B squared is 9. Here's the equation for my ellipse. We're going to work backwards. We're going to work backwards from the equation, see if we can come up with our A, B, and C values, and then sketch our ellipse. A, B, C. Remember, A is always greater than B, because this is half of the major axis, which is the longer axis, and B is half of the minor axis, which is shorter. So when I look at the A squared, B squared values here, the larger one will be A squared. So I know if A squared is 81, A is 9. This then is B squared, so B is 4, and C I can calculate using this relationship. B squared equals A squared minus C squared. So 16 equals 81 minus C squared. Be really careful when you're solving here not to get negatives and positives mixed up. So c squared will be equal to 65, meaning c is square root of 65. I know that's just a little bit more than 8. All right, so the center of my ellipse is 0, 0, because hk is 0, 0. The foci are at plus or minus root 65. I have to do plus or minus because there's 2 foci. And the vertices, they're out at the a value, plus or minus 9, not 3. Now, how did I know it was 0, 9 instead of 9, 0? Well, that's because the a value is with the y, which means this graph is oriented vertically. Center 0, 0, 9, it's a little bit off the graph, sorry about that, 7, 8, 9, negative 9. B is half of the minor axis, so I have to go out this way. And the foci are at plus or minus root 65, so that's just a little bit more than 8. They don't actually contribute to my sketching of the ellipse. And here we go. Not a beautiful ellipse, but we get the idea. All right, let's try this again, but this time given some different information. We're going to write an equation for this ellipse. Foci at 0, 3 and 0, negative 3. So make sure you go in the right direction. 0, 3. I'm going to label that focus 1. 0, negative 3. I'm going to label that focus 2. X-intercepts are 2 and negative 2. 2 and negative 2. And now I think about what am I missing? Well, I'm missing the vertices. And where is the center? And I need A, B, and C. It looks to me like this ellipse is going to be oriented vertically, which means that A squared will be with the y. I know my C value because that's center to focus. I know my B value because that happens to be the x-intercept. Remember, everything is centered. The center must be 0, 0, because that's halfway from here to here and here to here. And now all I have to do is calculate my A value. So remember, the relationship between A, B, and C is B squared equals A squared minus C squared. 2 squared is 4. I don't know A squared. 3 squared is 9. So that means A squared is 5. That is not right. A squared is 13. I have to add 9. So now when I write my equation, x squared over b squared, 4. Y squared over a squared, 13, equals 1. If I want to finish the graph, the square root of 13 is between 3 and 4. A would be the square root of 13, which is a little bit somewhere between 3 and 4. So for our purposes, this is exact enough. Try the next one. I encourage you to pause the video, see if you can figure out the graph and equation for this ellipse, and then restart the video and see how you did. I'm going to start by plotting the foci 4, 0, so make sure you go over 4 on the x. negative 2, 0. I'm going to label that focus 1 and focus 2. The length of the major axis, so remember this is the long way across the ellipse, is 12. The major axis goes through the foci and the center, so it has to be along here. I already have 1, 2, 3, 4, 5, 6, which means I need 6 more to get the length of the major axis. First, let me find the center. Here's the center. Center is 1, 0. Remember, that's HK. My ellipse is oriented horizontally, so my equation form will be x squared over a squared, y squared over b squared. Only this time, h and k aren't both 0. K is 0, so this is okay. H is 1, so I need, with the x minus 1 squared. All right, let's see what I have already. Length of the major axis is 12. That's the whole thing, which means A would be 6, half of the major axis. So from C, I go 1, 2, 3, 4, 5, 6 to get to a vertex. The other way, 1, 2, 3, 4, 5, 6 to get to the other vertex. And now I just need to know my B value. Let's see, A is 6, B I don't know, C is center to focus, that's 3, and I set up my equation. B squared equals 6 squared, which is 36, minus C squared, which is 9. That's 27. So when I write my equation, I have x minus 1 squared over a squared. A squared will be 36. Y minus k, which is just y squared, over b squared, which is 27, equals 1. Now, if I want to finish the graph, half of the minor axis will be the square root of 27, which is a little bit more than 5. So from the center, make sure you're at the center here, go 1, 2, 3, 4, up 5, and 1, 2, 3, down 5. This is really close to being a circle. A and B are really close to being equal. Next one, and then we're going to apply ellipses to some word problems. We're going to describe the graph of this ellipse. So by describe the graph, we want to identify the coordinates of the center, the foci, and the vertices. So let's start with center. That's HK. In this case, that'd be 3, negative 1. Remember, they're going to be the opposite of what they appear in the equation. And I need A, B, and C in order to find the foci. That's the distance from center to focus, is C. And vertices, which would be from the A value, distance from center to a vertex. Look at your equation. Remember, A is the largest of all three, A, B, and C. So that means 9 is A squared, so A must be 3. 4 is B squared, so B is 2. And then I can calculate C using my B squared equals A squared minus C squared. So that would be 4 equals 9 minus C squared. C squared is equal to 5, which means C is root 5. Let's graph this because then we can figure out the coordinates of the foci. 3, -1 is the center. A squared is with the y, so that means the ellipse is oriented vertically. So when I go to get my vertices, I go from the center up 3, 1, 2, 3, and down 3, 1, 2, 3. I'm going to label that vertex 1, vertex 2. So the coordinates of the vertices are 3, 2, and 3, -4. The foci are √5 units away from the center, which is just a little bit more than 2. And when I write the coordinates for that, instead of using a calculator to get a decimal approximation, I'm just going to take the coordinates of the center, 3, -1, and then from -1, I'm going to add √5 and subtract √5. So I'm going to say 3, -1 plus or minus √5 for the coordinates of the foci. And if I want to finish sketching my ellipse, I need the minor axis, so that comes from the b value. Make sure you start at the center, go over 2 in both directions, and try to make a neat sketch. There you go. All right, ellipses are in a lot of places in our lives, and we're going to take a look at just 2 examples here. An arch in the shape of the upper half of an ellipse is used to support a bridge that spans a river 20 meters wide. The center of the arch is 6 meters above the center of the river. Write an equation for the ellipse in which the x-axis coincides with the water level and the y-axis passes through the center of the arch. All right, draw a picture because then it's way easier to figure out what's going on. So we have the arch in the shape of the upper half of an ellipse. There you go. We're supposed to orient this with the x-axis on the water level. So here's the x-axis, and the y-axis through the center of the arch. So here's the y-axis. That means 0, 0 is going to be the center of my ellipse. Center, 0, 0. Remember, that's your HK. We're supposed to write an equation for this. Notice we've got it oriented horizontally. The center of the arch is 6 meters above the river. So from here to here is 6. The bridge spans a river 20 meters wide. So from here to here is 20. And here is the form of equation I want to use. And I know this because this is the major axis. It's the longest distance. So A has to go with the x, and B has to go with the y. The center is at 0, 0, so HK are both 0. And just by looking at my diagram, I already have my A and my B. Half of the minor axis from center up to here, there's not really a name for that point, is 6. So my B value is 6. A, remember, is half of the major axis, so half of 20 is 10. And all I have to do is put in my numbers. So h and k are 0. I'll just have x squared and y squared. A squared will be 100, and b squared is 36. There's my equation. Last one, a whispering gallery. So this is a really cool acoustical feature of some buildings if they make the ceiling in an ellipse. Okay, here's the floor of a whispering gallery. And a whispering ceiling, 3D, but we're just going to go with 2D drawing, of course. You're standing at one focus of a whispering gallery. It is 6 feet from the nearest wall. Your friend is standing at the other focus 100 feet away from you. What is the length of the whispering gallery? How high is its elliptical ceiling at the center? All right, so here you are at a focus. You are 6 feet from the nearest wall. So from here to here is 6 feet. Your friend is at the other focus 100 feet away. So from you to your friend is 100 feet. What is the length of the whispering gallery? Well, I got that pretty quick here because if I'm at a focus 6 feet away from the wall, and this is supposed to be all symmetrical, your friend has to also be 6 feet away from the wall, which means the length of the whispering gallery is 112. I'm going to put units on it, 112 feet long. Okay, next, how high is the elliptical ceiling at the center? So I'm going to move this 100 feet below because I'm looking for this distance now. So think about what that distance is in terms of an ellipse. This is the b value. This would be like half of the minor axis. We can use this relationship to find b. Let's see. We know a, at least we can figure that out, because a is half of the major axis. So from here to here is half of this entire length. So A is 112 divided by 2. C is the distance from the center to the focus, which would be half of 100. And then your calculator will do the rest of the work for you. B is approximately 25.2 feet. So the ceiling is 25.2 feet high. If you have any questions, make sure that you ask them next time I see you.